long, arduous process to actually counteract?
No, because my advisor is the head of the climate change, but she's already signed off on everything.
Oh, I meant after you get your minor, you
Oh.
want to apply that.
Yeah. Well, I'm going straight to Kathmandu.
Is there a song about that?
Yeah, I think there is.
Hey, so here's what I wanted to just show you, some of our alums. So here's Allison Sweeney. She was one of the first folks to come through the program, and she was working with Liquid Solar Systems. A lot of their work was seasonal. You know, if you're there in Bozeman, you're typically not getting up on the roof in the winter. But she was also part of the team that built that small wind turbine in the back. So the turbine in the back was all hand wound.
This right here?
Yeah, this is the blades. The blades are there on your left. This is the turbine itself. And
These are the blades.
yeah, right
The
there.
white ones? Okay.
And so this stuff. So this is what we did in the practicum. So we bought a few 100-foot spool of wire. This was a little bit bigger a few days ago because Gary Orem is actually building a levitating wind turbine right now. It's out of that same one that we did at the hydrogen fueling station. So I'll show you their report. This is one of the best reports I've seen come out of the energy practicum. So, as you know, the Energy Tech program has a lot of courses. The practicum is just one of them. And let's see, if I'm not mistaken, this was Wind Power Team Report 623. So this report's 5 years old now, but still valid. So relatively small turbine. There's a sketch.
Did you have to pay for this? $20?
Did I have to? Oh, no, did I have to pay to get my own report? Good question. Yeah, Will Smith was a student. Yeah, something Prince of Bel Air.
Fresh Prince?
Fresh Prince of Bel Air was here in the classroom. No, different Will Smith. I haven't kept up with him much, but Art Vanderay, he's a teacher up in Kalispell. Randy Jones, haven't kept up with him much. Chris Maramato works over here at SATIC in town, building power correction factors. Last thing I heard from Cole, he was out in Oregon and Washington doing solar. Allison Sweeney, I just mentioned. Andrew McChain has his own business here in town called Battery Doctors, so he'll do battery refurb. Mike Jacob has done a lot of work with Andrew McChain. They have a little startup called My Solar Cart. They'll put solar panels on just rigs and job boxes and things, in the field. And then I haven't heard from Will much lately, but this was one of our first practicums.
I think he became king.
Yeah, he got famous in
Yeah,
Colorado.
he
Oh,
got promoted.
good. That's good.
No more French, he became king.
Right. But so this is showing some of the analysis. So in order to build the turbine, they went through and said, what's the best number of coils? What's the best number of magnets to put this together with? Table 1. This is how the magnetic field in a system relates to the change in electric potential. So you're moving magnets and making electricity with them. Here's the rotor design. So as the rotor moves past the stator, electricity flows. They put it together, and they just grabbed this out of a kind of a how-to, hands-on textbook from Hugh Pigott, and we use Pigott in NRGY 242. They set up their own coil winder, otherwise, pretty arduous. So just a little hand crank spool. And then this is more or less the wiring diagram. So the whole generator is one big long wire if it's single phase, or 3 sets of these if it's 3 phase. So that's their own work sitting there in the back of the classroom. the reason for having this, this pipe at this angle, if the wind speed gets fast enough, and the wind turbine's just sitting there spinning, it can actually blow hard enough that the blades either like fly off from some centrifugal force or bend back or some combination of both. So if you put that tail at an angle, once the force becomes great enough, the whole turbine just turns sideways, so it doesn't blow itself apart. It's actually perpendicular to the wind instead of or parallel instead of perpendicular. Yeah.
Did one of those students do metal fabrication in the classroom?
Actually, Allison Sweeney's husband did that, but we've also collaborated with the welding department. They welded up frames for our Shelley Marathon cars, and yeah, we've had physics students come through. Hey, I want to weld. And there you go. We'll set them loose. So, yeah. So that's the finished turbine, and they did get some data, but at the end of the day, what you'd really like to see is a data set. So anyway, that's Allison Sweeney. Hear from her from time to time. Brandon Hauser was working with Sinelco. They recently sold the owner, Tom Bishop, now does renewable energy systems out at Axman. But right out of the school, Brandon got a job working down there in Victor. So staying local. Lori Pratty, she's one of our more illustrious alums. So she came through, and she actually got her AA, AAS, and BAS kind of all at the same time. So with the AAS, 50 of the 60 credits transfer directly into a BAS. We have other students go on. She took some computer programming, a little more physics, and for McKinstry, what she mainly runs is energy conservation software. So if someone says, hey, we want to figure out what's the best place to put in the insulation, or do we spend money on windows or lighting, that's the kind of analysis that Lori runs.
Like the envelope.
Mm-hmm.
Does that make sense?
Yeah.
I think is what it's
Yeah,
called, like the
yep,
envelope?
yep.
Okay.
So, how do you maybe add some day lighting so you don't have to keep the lights on as much? You might put in a solar thermal feature of some type so to cut down heating bills. Martin Knight, I've heard from him recently. He did have a little stint with Energy Techs here in town, mainly just crawling around putting insulation in, but he was also has an MBA, and I think since I talked to him, he might even have a master's degree in environmental science. So he's been working on how to involve renewable energy technologies out in the remote field. So like say you want to put in a wildlife monitoring system, or some way to help salmon navigate the river, what have you, and it needs a little bit of power. That's mainly been Martin's forte. Really neat guy. Yeah, I just,
I like that.
yeah, he's a supreme human. Let's see, who else? Where was
So is the energy program that, is it like a minor, or like what is this, the energy?
Energy technology is a
Yeah.
major.
It's a major?
Yep.
Okay.
Yeah, we have 70 or 80 alumni now.
Okay.
Here's a couple of projects that we did. So this is our Shelleyco Marathon vehicle that we took down to Houston. This was a e-waste recycling project. So one summer, one of the students came in and they pulled, gosh, about $2,000 or $3,000 worth of gold, silver, copper, platinum out of about 100 computers. So these were all computers that were on their way to California that the university just gives to this company. We don't make any money on it, but these students with about, gosh, maybe 100 or so dollars worth of chemicals we just bought at the Ace Hardware. We were firing gold ingots by the end of 2 weeks. And there it is. I mean, look at those chips. Those are some juicy gold chips right there.
You look like little wafers.
Yeah, they are. That's Tom Gallagher. He was our department chair at the time. And then this is our solar car. So Jeremy, I have not heard much out of him. He was doing some construction. Oh no, I can't believe I'm blanking on her name.
Sally.
No, it's not Sally.
Nancy.
It's so funny on the tip of my tongue. But anyway, she's still in school. She's over at Bozeman getting her engineering degree. It'll come to me in a second. Sean Ronning is working for his father's power company. They'll do a lot of logistics, putting in big power lines. Last time I talked to him, he was directing helicopter traffic in Pennsylvania on new big power lines. Grant Myrie's working on his engineering degree at Tech. There's Andrew with Battery Doctors, the guy I just mentioned. Yeah, I'm going to blank on his name too. Come to me, but he lives more or less off the grid in the Yak. So and then and here's Michael Edom, and he's still pursuing a undergrad degree too. And there we are at the wind farm in Judith Gap. It's worth noting that we've had 2 graduates work at the Judith Gap wind farm. One's Robert Holter. He's now working as a wind farm technician in Nebraska. And another one, Ryan Carson, currently works there. He was a Iraq war vet in the mechanized unit. The guys that are out there doing the IEDs and fixing the big tanks. But now he gets to work on wind turbines for a living.
Less stressful.
A little less stressful.
One of my friends, he did the wind turbine mechanic
Yeah.
thing in Oregon, so now he just goes around replacing or working on wind turbines.
It's a good gig if you can get it. And
I always thought if he could do it, anybody can do it. Is that guy?
yeah.
I've been trying to get in touch with somebody here in town who does like a bicycle powered washing machine
Uh-huh.
or dryer like that.
Yeah.
Do you know who designed that?
That's mine.
That's yours?
Yeah.
Are you serious, Brad?
Yeah.
I'm not even kidding. Right now.
I still have it.
You still have it, really?
Yeah.
Search it over.
Could it be hooked up to a washing machine too, that same design?
Yeah, there it is.
Funny that you ask.
I'm serious.
Okay, we're bringing back
Well-
after
Well, for the
Thanksgiving.
cause,
Sure.
I think that we need to get one out to Standing Rock.
Well, I'll tell you the story before you get too excited about it. I'll tell you the story.
Well, it doesn't work very well.
Well,
I'm just kidding.
I'll just tell you the numbers. So anyway, so this gentleman here, this is Mark Olson. He was a mill worker and has done a little bit of adjunct teaching for us. And he's working over at Albertsons right now. This is Remington Rehis, and I have not kept up with him much, but I know he's a avid hunter and native Montana. This is Cindy Corpy. One of her first jobs right out of the program was to go work for a company here in town that won the Carbon X Prize. So they're doing CO2 monitoring in the ocean. Sunburst sensors. Sunburst sensors right here in town. This is Josh Eamon. He was part of our human-powered vehicle team a few years ago. Haven't heard a lot out of him recently. There's Greg Guccio. He's got his own solar panel installation company here in town. I'm not sure exactly who that is behind him. Another student. So anyway, those are some of our alums. But let me just, since you asked about the human-powered washing machine, I'll just kind of show you some of the realities here. So we built a dryer, and we'll just start with a dryer first. So here's your dryer, and you're going to have what we did. We have some energy mechanical coming in, and we also had energy electrical coming in. Right, because you need the mechanical to spin the drum, and then you'll need the electrical for the heat. You could also, you could also imagine having a gas dryer, burning some combustible gas. So in terms of human power, so let's do it this way. One human power, as we know, equals approximately 1/5 of a horsepower. So it gets real in a hurry. So one human power is maybe 200 watts, and a horsepower is well, I'll just say 100 to 200, 100 to 200, and a horsepower is 750 watts. And now let's just go out and look at
Energy requirements for the
yeah, let's just look at it.
ridiculous.
Plate requirements for dryer, clothes dryer. Images. Okay, let's just pick one of these guys here. Okay, so if we look, 120 volts AC, 60 hertz, 14 amps. Now, this is the Speed Queen, so there's no, okay, so it says it's equipped for natural gas, and we can run this thing too. Let's just run both. So we'll run the power requirements for the dryer on both a electrical basis and a thermal basis. It's actually a pretty good problem.
Just pushing the pedals does both of those, you're saying?
No, we had two sets of pedals.
Okay.
From the we had two sets of pedals. One to spin the drum.
Mhm.
So one set. We had a little chain on here. Spins the drum. That's the mechanical part, and then the other one.
Bunch of straws of people blowing in hot air.
Yeah, ran the coil. Well, no, we just ran a we just ran a generator to pump electrons through the actual coil of the dryer.
Yeah.
Okay. So here's the nameplate. So there's 120 and 14. So let's just run that.
This is amazing that you do all this stuff.
Thanks. So power equals volts times amps, volts times current. And if we're running at 120 volts, the current, what did we say it was? 14 amps. 14 amps. And so, fortunately, volts times amps, watts, 120 times 14 equals 1680.
And that unit was what?
80 watts.
Okay.
Right, so then we'll just divide that. Let's just be generous and divide it by 200.
Is that, you're talking about that's a human?
A human power is
Okay,
200.
okay. I was just making sure I was.
Yeah.
on the same-
So to do this properly, you need 8 people running the thing in a reasonable amount of time.
If you wanted to actually.
Yeah. So I'll say 8 human power.
At the same time.
Yeah.
So you have 8 different bikes all get theoretically to
To
the
one
one.
thing.
Yeah, but if you look at this, most of this is probably about 200 watts here, and your additional let's just say 1,400 are over here. It's in the heat. What you're doing, you're turning water into steam. That's really what you're doing. You're turning water into steam. The spinning is relatively
That's frivolous
modest.
because it's just, it's just whoever.
it's about the same as just riding a bike,
Yeah.
to spin that drum. Yeah.
So have you heard of the wind-powered washing machines?
I have not, but that would be a good one because
Cool, because washing machines, at least it's just the mechanical thing.
Yeah.
That's really needed.
Yeah.
And then with a dryer, it seems a little tougher. 'cause
Yeah.
you need the heat and the mechanical.
Yeah, so
But they actually did a design for that in Vietnam.
okay.
That's where they originally came out. Oh, you're going to Vietnam, cool. Well, then why don't you tell them? You need that design for the
They have but I've seen like,
It's super easy, it's actually really good design.
yeah, there's, I've
You
seen
know
like,
what I mean?
like the workout bikes that you have, but underneath is like a washer. So as you're like.
No, with the wind-powered one, you may not even need
Underneath is like a little washer.
to convert it. You could just continue the mechanical energy.
Just,
down.
yeah, just, and that's what we found, is just the clothesline or.
It's very simple. All you need is time.
Yeah, that's right, that's right.
I lived in like
165. I'm just gonna run the BTUs really quick here too.
Developing countries.
I'm thinking it's
They found that giant fossil, that was cool,
Where?
under the pipeline. There was like a giant 30-meter long complete dinosaur fossil that they
I
found.
guess
under
that
the
standing
pipeline.
run, I think, kind of hit the shit of the fan yesterday.
Oh, let me guess.
That
They'll-
whole
they'll
Water
stop
cannons
bulldozers
and freezing
for that.
I know.
temperatures,
Yeah.
160.
And I guess fucking archaeological remains of me.
That's not really, it's not clear to me who's actually kind of in charge of the security, but yeah, it's,
But,
Oh, yeah, so they're gonna stop, to be able to dig it
I
up?
agree that. They have to.
Seriously?
I would imagine, I mean, you can't go
Dinosaurs?
over dinosaurs, that should be
Oh,
any species.
no, God forbid.
Yeah.
okay, so we're gonna do the BTU conversion now,
First
so,
thermal unit.
yeah, so 165,000.
Office, your ancestors, dinosaurs,
Sorry.
power, I'm so stupid.
It's okay, I'm still on target, you guys can go down whatever rabbit hole you need to. So 165,000 BTUs per hour. So it's worth noting that BTUs are unit of energy, and so 165,000 BTUs are 48 kilowatt hours, so let's run that. So 48 kilowatt hours. Per hour. Now, let's see, that seems like a lot.
Ridiculous.
165,000 BTUs per hour. I mean, that is the power. I mean, that's the thermal power
That's a
flowing into
lot.
that guy.
That's a lot.
Yeah, it
Because
is.
the Army has 125,000 BTU space heater units.
$1.25.
About 25,
Yeah.
that's what we do.
Well, that's what this is. It's a space heater, so 165,000 BTUs per hour. Okay, so let's just run it. So what it says is this much energy per hour. So this much energy per hour equals 48 kilowatts equals 48 kilowatts. Hang on. Yeah, 48 kilowatts. 48,000 watts equals, well, 2400. No, come on. I'm having trouble here. 48,000. 240, that's better. Keep up 0 there.
What school am I standing on here? Mark Woodfield, he's the whole.
Oh, he is, yeah.
He's the.
Yeah, I saw him
solar
go out
panels and stuff. That's cool.
Yeah, so you need 240 people to equal that gas input.
For that 185, whatever BTU, or
So
165.
I did look when you're on the
Wow.
other page. Don't look so sad. I did look when you're on the other page that the particular dryer that you picked though, it's called the Speed Queen.
Yeah.
And it's a
Yeah.
natural gas dryer,
Yeah.
so
Yeah.
might be able
So,
to
yeah,
find-
so what my students actually dubbed, so they sat there and they tried to dry the clothes, right? And after staring at each other for an hour and opening the thing up and like, still not dry, they said, well, if we actually bought this, if we were married, we bought this, we would not stay married. So this is the divorce dryer. But to get back to it though, to get back to it though, if you had, let's just think about this for a second. If you had something like this, where, and again, human power can run the motor. But let's just say you had some solar thermal technology here. Then you had a hot water tank here. You could use the sun to heat the water, and then you could have your bicycle power running the motor.
How effective would that be, though? That wouldn't be, that doesn't seem like it'd be enough to supply it.
Like what would be enough to
Energy,
supply what?
Just like this heating up the hot water for it, it doesn't seem like there'd be enough to keep up with the demand.
Well, just make it bigger then.
Sure.
Yeah.
All right, when in doubt, get a big hammer.
No, I mean, the power of the sun, going back to this, is it's 1,000, power of the sun is 1,000 watts per square meter.
Mm.
So if you go back to this, this first guy, what we were,
14 right there on the side.
yeah, we were looking at is
So if you just
four.
did 2 panels then at that point,
yeah, so
then
just,
it'd be enough.
yeah, two square meters
Okay.
would be sufficient.
I didn't know if I just wasn't tracking at first on that.
So that would be, so to get the thermal power,
They have solar panels out there.
solar thermal or solar PV?
Use solar PV.
Yeah, but solar thermal would be a way, and we've built a bunch of these up in Browning, actually, solar. We were getting some nice hot water out of them.
It's a great idea.
Yeah,
too,
yeah.
'cause I get the feeling they'll have enough hot showers here and there.
Yeah. Well, okay, well, that's my suggestion. If you want to see the dryer, it's in the museum. I've got it still.
Sweet.
Yeah.